Hey guys, welcome back. In this video, we'll be trying to solve the problem of the day on Geeks for Geeks of 19th November. Alright, path with minimum effort. So you're given a 2D array, a matrix of size n into m. You have to find out the minimum possible path cost from the top left cell to the bottom right cell. Alright, so basically the path cost is defined as the maximum absolute difference between the values of any two consecutive cells. So let me explain what that means exactly. This is a very straightforward problem. Okay, so let's take this example. All right, this is your matrix. You have 7, 2, 6, 5, 3, 1, 10, 8. Okay, now 7 is our starting index. So basically, from 7, we have to take 3 because the absolute difference between 7 and 3 is the lowest, right? Then from 3, the only path is 1, right? From 1, you can either go to 2 or 10. The minimum difference is 2, so you go to 2. And similarly, you can do the rest. Follow the same procedure for the remaining nodes as well and reach till the end. All right. So let me first explain as to how this works. Okay, how we plan to do this. So we'll be having a priority queue. What we'll be using. Okay, and this priority queue will just be storing three particular attributes. Okay, that is your distance. Okay, then your row and the column. Basically, at which position you are and the distance to reach there. Now we'll be expanding it based on that. Okay, so the first thing you have to do is you have to find out the distance between your neighboring nodes, right? So I'll be taking like example by example and going. Now, if you see 7, from 7 you can either go to 2 or 3, right? So if you go from 7 to 2, your difference is what? 7 minus 2, that's equal to 5, right? Now, if you go to 3, your difference is 7 minus 3, that's equal to 4. Here, 4 is smaller, right? So we have to go to the path in which the difference is lowest. That is why this 3 is being expanded in the beginning. Okay. Now from 3, you only have one particular place or node to go to, and that is 1. This we go to 1. From 1, see, in this, we are not going to explore the visited nodes again. Okay. So like 3 is visited already, so there's no need to explore it again. Now the unexplored nodes are what all? We have 2 and 10. Now if we take the average or like the minimum distance between 1 and 2, it will be mod of 1 minus 2, right? Answer is 1. Now if we take the distance between 1 and 10, mod of 1 minus 10, answer is 9. Right, again we have to choose the smallest path. So we'll go to 2. Now from 2, the only path is 6, right? Because we can't go to 1 again, it's explored. From 6, you have two paths, that is 5 and 10. Now for 5, 6 minus 5 will be equal to 1, right? 6 minus 10, well, the mod of it will be equal to 4. Alright, to again choose the lowest path, so we go to 5. And from 5, you only have one path, that is 8. Alright, so that's basically it. Now, each of this info, what we'll be having here, like the information of the minimum cost, we'll be adding it to our priority queue with the required row and column of that particular index. Okay, now we'll keep on doing this till the end, and we'll just return once we reach the last um the last node of our matrix. All right, yeah, that's basically it. Now let's see as to how we can solve this. Okay, so let's code this out. The first thing we'll do is create NNM, right, to be the length of your matrix and the length of the first index. Makes it easier. Okay, so now here's the priority queue, right? We have min cost, which will be equal to float of negative int, because initially we have like negative int path, right, for everything. Basically, we didn't like initialize it yet, so we just put it as minus n for now, right? Star m for blank in range n. All right, as simple as that. Now, I'm sorry, like this is not your priority queue. This is the array to keep track of your main cost. Okay, my part. Now, priority queue is what we're making right now. Okay. Now, in this initially, we'll be putting it as 0, 0, 0. Now, this being that this is the first index you'll go to, right? So the first index, like the distance to reach that is 0, right? And the row and column is also 0. So that's why we'll be initially like initializing PQ as 0, right? After this, we can just set min cost of 0, comma 0. 0, 0 as equal to 0, right? Because it's your first node, you don't have to pay anything to reach there. Now we'll also be having an array called dirs, which shows you the possible paths that you can take, right? So you can either go to the you can either go up, that is xy, right? So y is equal to 1, or you can go down, so 0 minus 1, or you could go to the right, or you could go to the left. All right, that's basically it. Now after this, you have to perform this loop till the priority queue is not empty, right? So till we have some path to keep on doing this, just so that we can explore every single node. Okay. Now we'll have maximum difference, right? Which is the difference we have right now. Comma r comma c. Right. Now this will be equal to keep q dot pop dot keep pop of pop. Okay, and this is basically how it works. So basically, you'll be popping each element from the heap, and you'll be storing it inside these variables. All right. Now, if your max difference, right, if that exceeds your min cost of that particular node where you're at, we can just continue and go forward, right? Because we already have a cost lower than that, so there's no need to move forward. Now, if r is equal to n minus 1 and c is equal to n minus 1, basically we reach the last node, we can just return max difference, right? Because that's the last node, we can just output the answer then. Now for dr comma dc in dirs, for every single path which we could take, right, top, left, right, and down, we have to explore every single path, right? So what we can do is we can just do nr comma nc, basically new row, new column, will be equal to r plus dr and c plus dc. All right. Now, if your nr is more than or equal to 0 and is less than n, right? And we can do the same thing for nc as well. If this is the case, then what can we do? We can directly set edge weight, which will be equal to the absolute of matrix R C minus matrix NR and NC. Right, so like this is basically how you calculate the weight, right? The node which we are in right now, and the node of the, the weight of the node in which you are in right now, and the weight of your new node, right? That's how you calculate the path, right? So that's how you do this. Then you can also perform, let's see, new max diff, right? Your new max difference after going to your new node, which will be equal to the max of max diff, what you had previously, or the edge weight of what you have right now. All right, that's it. Now, if new max diff is less than min cost of NR and NC, if so, then we can directly set min cost of NR and NC will be equal to new max diff, right? Straightforward. Let's see now. Yeah, then we can push this into the heap because we found our new path. So heap q dot heap push pq. We're gonna push into pq, and what should we push? New max diff and RNNC. All right, that's basically it. Now at the end, you return min cost of n minus 1 and n minus 1, basically our last node. All right, let's see if this works. Okay, we're going to be doing it for float in. My bad. Let's see now. Okay, it works. Let's submit. There you go. That's how you solve this problem. If you have any doubts, do let me know down below. And that's it for this video. I'll see you in the next one. Goodbye.